Good day, everyone. I am Aaron Ezekiel Haramia, and welcome to the third lecture of the biology curriculum entitled Energy. This part will focus on the introduction to bioenergetics. In this presentation, we will focus on three main topics: types of energy, laws of thermodynamics, and enzymes. So, first, let us define energy. So, what is energy? Energy is the ability to do work, where most things and processes depend on it, allowing to cause some change. Virtually every process on the universe depends on energy, as energy allows things to work. That is why most things depend on it, and it allows change to happen within those things. It is never created nor destroyed, rather converted from one type to another. It is not a material that can be created and destroyed, but rather it is an entity that can be transformed from one form to another. Life ceases to exist without the ability to obtain and use energy. Along with other materials in the universe, us organisms also depend on energy. Without energy, we may not able to accomplish our tasks that is vital for survival and living. So, additional information: energy is from the Greek word energia, meaning activity and operation. And energia is derived from the root word energos, meaning active and effective. This explains us that energy is the term for operation and activity. So, as we have mentioned, energy can is an entity that can be transformed from one form to another. And by that, energy can appear in many different forms, such as light energy, heat energy, electrical energy, and nuclear energy. But in bioenergetics, which is the study of the energy transformations taking place in organisms, we will only focus on three general types of energy. We have kinetic energy. It is the type of energy associated with movement and locomotion. The opposite of kinetic energy, we have potential energy, the type of energy at rest associated with an object's position or structure, and chemical energy, which is a type of potential energy stored in the chemical bonds of a substance. So we will tackle these three types of energy on the further discussions that we will have on this lecture. So for us to have an overview of the types of energy, we have two main divisions. We have kinetic energy and potential energy. As we have previously defined, kinetic energy is associated with movement and potential energy is associated with rest. So when an object is moving, when an object changes its position from one place to another, it exhibits kinetic energy. Meanwhile, when an object is at rest, it doesn't move and it does not change position. It exhibits potential energy. It stores potential energy. Under kinetic energy, we have five types. First is motion energy. Energy stored in a movement. When a car is moving from one point to another, when a child is running, when a planet is orbiting around a star. These examples exhibit, or these objects, exam, example objects, these objects exhibit motion energy, for they are moving and they are changing their positions. So motion energy is a type of kinetic energy. Radiant energy is the electromagnetic energy that travels in transverse waves. So example of this is the sunlight. So sunlight is a form of electromagnetic waves that travels in many different parts of the solar system, and also in the earth we are receiving radiant energy from the sun. And radiant energy from the sun has many practical applications, such as the photosynthesis that we will discuss later on, and solar electricity. Next is thermal energy. It is the energy that comes from the movement of atoms and molecules in a substance. So thermal energy is specifically on the molecular and atomic or molecular state of a substance. So when the atoms of a substance moves quicker, the hotter the substance it becomes. When the atoms of a substance moves slower, it colder, it it is less hotter it becomes. And thermal energy is also described, or it is also known as heat. So it measures the hotness and coldness of a substance based on the movement of the atoms it has. Next is sound energy. Sound energy is the movement of energy through substances in longitudinal waves causing vibrations. So our vocal cords produce sound energy for our vocal cords are vibrating, and these vibrations are caused by the longitudinal waves. Yeah, the longitudinal waves. And these longitudinal waves produces movement causing vibrations. So yeah, example is our vocal cords. Another is musical instruments producing again longitudinal waves, and these longitudinal waves producing vibrations, which in turn produce sound that we may not hear or may hear, or yeah, we may not hear or hear by our ears or a sense of hearing. Lastly, for kinetic energy, we have electrical energy. It is delivered by tiny charged particles called electrons. So recall your grade 8 chemistry. Electrons is a subatomic particle of an atom, and typically it is charged. And when it is charged, it exhibits electrical energy. So practical applications of this energy would be the electricity we are using for our daily lives and the lightning, which is a natural occurrence. Next, potential energy, we have four types. Chemical energy is the energy stored in the bonds of atoms and molecules. So, as we have mentioned a while ago, chemical energy is a type of potential energy that is stored on the chemical bonds of substances, of the atoms and molecules of the substances, and it is ready to be transformed into kinetic energy by chemical reactions. Mechanical energy is the energy stored in objects by tension. So, for example, we have a rubber band, and then we stretch this rubber band. As we stretch this rubber band, the rubber band stores potential energy as it possesses tension. So, the greater the stretching, the longer we stretch the rubber band, the greater the mechanical energy. The lesser, the lesser, the lesser stretching we we are doing with the rubber band, the lesser stretching, the lesser the mechanical energy it stores. So when we release the rubber band from the stretching, it transforms the mechanical energy into motion energy, which is a type of kinetic energy. Next is nuclear energy. Energy stored in the nucleus of an atom, the energy that holds the nucleus together. So in electrical energy, we have mentioned that it is the electrons that takes charge of the electrical energy. In nuclear energy, the nucleus of the atom making the nucleus of an atom made up of the protons and the neutrons takes place in storing energy, which is nuclear energy. So nuclear energy uh, holds the nucleus together, holds the protons and neutrons together, and there are many applications of this. So when we release this nuclear energy, we are also uh, breaking down the nucleus of the atom. That is why we have nuclear fission. So when we are trying to fuse the nucleus back together, we are doing nuclear fusion. And this nuclear reactions that we are having is very vital in many applications such as electricity. Uh, yeah, and electricity is an example of application of nuclear fusion and fission. Lastly, for potential energy, we have gravitational energy. It is the energy stored in an object's height which is released through gravity. So, gravity is the main driving force of this gravitational energy. And gravitational energy is very dependent on the position of the object. So, when an object has greater position or greater height, the greater gravitational energy it stores. Meanwhile, when it has lesser height, it stores lesser gravitational energy. So when we release the object along with the gravity, the stored gravitational energy will be converted into kinetic energy. So you can see that energy can transform not only in one form to another, but in any form may that is possible or that is present in the universe. So these are the types of energy that we have. This is just an overview of the types of energy. I know that there is many energy present in our universe, and this we have mentioned are some of it, and that is why, yeah. So why is energy important in organisms? As we have mentioned, life ceases to exist without energy. We are very dependent on the use of energy. We cannot run, we cannot walk, we cannot do our daily chores, we cannot accomplish tasks without the use of energy. That is why where that is why if we don't have energy, we may not survive. We may not exist. So virtually every biological process requires energy. In cellular level, energy is very crucial because it is constantly being used for different processes such as breaking down of nutrients, synthesis of new molecules, transport and distribution of nutrients. So, as you can see, energy is very important for us organisms. In order for us to fully understand the essence of energy in biological organisms, we are going to discuss the laws of thermodynamics. So there are two laws of thermodynamics that we need to understand, the first law and the second law. So we will talk about in the next slides. So the first law is the law of conservation of energy. It states that energy cannot be created nor destroyed, but it can only change form. Yes, so as we are continuously repeating in the previous slides of this presentation, energy is an entity that can appear in many different forms, and it can appear in many different forms through transformation of it. So we cannot make energy, we cannot destroy energy, but we can transform it in many different forms. So we have two examples here. Uh, the radiant energy from the sunlight is converted into chemical energy by the photosynthesis of the plants. So we will talk about photosynthesis on the next part of this presentation or of this lecture. So as we can see, from radiant energy, it is being transformed into chemical energy. Still, it is energy, but in different appearance or in different form. Next example, we have an apple on a tree. So the apple in a tree, or the apple hanging in a tree, stores gravitational potential energy, and then when the apple falls to the ground, the gravitational potential energy converts into kinetic energy. So from gravitational potential, it is converted and transformed into kinetic motion energy. So that uh, the first law explains us that energy is not immaterial but an entity that can be transformed from one appearance or one form to another. Now, the second law of thermodynamics, or the law of entropy, states that energy cannot be transformed without the loss of usable energy, which contributes to the entropy of the universe. So first, let us define what is entropy. So entropy is the measure of disorder or randomness of a universe. So when we transform energy, it is not all the time that from the original energy, we will transform it 100% to the next form of energy. It is not like that. uh, when we are converting an energy into useful energy, some of the energy are also being converted into useless energy. And this useless energy contributes to the entropy or the randomness or disorder of the universe. So without this randomness, or without the transformation of without the presence of the useless energy being transformed from the previous type of energy, we cannot acquire, or we cannot obtain the useful energy that we have, or that we are wanting to obtain. That is what the second law of motion, or second law of thermodynamics, tells us, that energy cannot be transformed without the loss of usable energy. So the usable energy will lose some of the so the usable energy that we are converting will lose some of it, and this loss will eventually turn into useless energy. So what is the implication of this second law? So as we can see, we have this energy pyramid, and the and uh, as we recall the energy pyramid, the energy that is being transferred from one organism to another decreases by 10%. So the 10% of the energy is being released in the universe as useless energy. So this is a manifestation of the second law of thermodynamics, that it is not 100% energy is being transferred from one organism to another. It is uh, it is vital for useless energy to be released outside the universe, and this useless energy contributes to the randomness, to the entropy of the universe. That is the second law of thermodynamics. So, usually the useless energy that we are releasing as organisms is thermal energy or heat. Next, we will talk about enzymes. So some reactions are slow in normal temperature, or some of the reactions may not uh, occur on its own, and it does need some driving force in order for it to occur or to be accomplished. That is why we need some catalyst or a substance that helps a chemical reaction to occur by lowering the activation energy. So first, what is activation energy? Activation energy is the energy that is required by a process in order for it to occur. So this catalyst will lower the activation energy. It will lower the requirement for a process to occur, which will quicken the process and with it will allow the process to occur or to be or to materialize. That is the job of a catalyst. And an enzyme is a molecule that catalyzes biochemical reaction. So an enzyme is a catalyst because it uh, speeds up the process of many different biochemical reactions. So there are many enzymes that we are going to talk about in the future discussions of this lecture. And they are helpful and they're very essential for us organism because without them, our processes may be slow, and may not be occur in its own. That's why we need enzymes. So how does enzyme works? So enzymes works by binding into substrates in an active site. So when we say substrates, it is the reactants that we have inside our body, inside the body of an organism. So the active site is where the chemical reaction takes place. So the enzyme will bind to the reactants or substrates in an active site. So when an enzyme binds its substrate, an enzyme substrate complex is formed. This complex lowers the activation energy of the reaction and promotes its rapid progression in one of multiple possible ways. So, as we have mentioned, it speeds up the process of many biochemical reactions because it binds to its substrate and it forms substrate complex, enzyme substrate complex. So, this enzyme substrate complex lowers activation energy and promotes rapid progression of the chemical reactions that we have in our body. So we will talk about more enzymes in the future discussions or in the next part of this lecture. So that is all for this part. I will see you on the next part of this lecture, which is the metabolic pathways, in which we will talk about photosynthesis and cellular respiration. Thank you guys for listening.